Good morning, good evening. This is Lakshman Eluri, and I am looking forward for to explain time series analysis here. So, Global Mart is an online superstore giant having worldwide operations. It takes orders and delivers across the globe. It deals with three major products: consumer, corporate, and home office. However, the goal here is to identify two most profitable consumer segments or profitable markets or segments using time series analysis. We need to forecast it to 6 months. We need to forecast the sales and demand. And here, the time series analysis, we followed the time series smoothing techniques. We also followed decomposition method and ARIMA process. As a standard process, we understood the business understanding. We had the data understanding. As there are 21 segments, and out of that, there are 21 business segments. Seven segments need to be were there, and out of that we need to identify two profitable market segments and forecast it. That's the data part of understanding. And also the standard process is to check for any null values or non-number values which is not accepted, and also check any inconsistencies like any other numbers, non-numbers, non-numeric numbers, etc. Is there any duplications, and converting some of the non-date formats to date format, etc. are taken care, and outlier analysis also has been done. Now, once this is done, we straight away divide again the entire data set into try and certain data set, and we start building the models. And coming to the classical decomposition model, we first look into the global predictive model, which is a regression model which we built here. And then we look into the global predictive model and subtract the time series data and check if the residual is white noise by applying Anderson Darling test, which is called ADF test. Model evaluation is for the classical decomposition motion is use the model built to predict the values of for the next 6 months and calculate the MAPE, which is an error for the classical decomposition. So the difference between the forecasted and actual values it will give you the MAPE value in terms of percentages. And then we come to the AutoArima. AutoArima is auto regressive integrated moving average method, whereas we first build a global predictive model with auto data rima and then subtract the global predictive values from time series data. Check if the residual is white noise by applying again the ADF test or KPSS test. And Anderson Darling test is will be connected if we reject saying that if we if the value is less than 0.05, we reject the uh, stamp series is stationary. Likewise, then once we build a model in AutoArima, we go to a model evaluation and use the model built to predict the values of the next 6 months and calculate the MAPE again. So the MAPE here is again the difference between the actual value and the predicted value. It should be ideally smaller for a better forecast value. That's how the forecast has been done. And coming to the classical deposition method and auto-rima, which are used, which you need to test it for every time series to look into the accuracy. This is basically on the time error method. And auto-rima, once auto-rima or forecast libraries have been used, you will be able to get the forecast for it. And here you can also use time series smoothing method because to smoothen out any random fluctuations, and you will get a nice smoother curve, leaving all those white noises or the random events or one-time sudden events that may happen. Uh, White noise is something we have global predictive part, which is the long-term trend, and then we have local part, which depends on the immediate previous values. Apart from that, we also have a white noise, which is very purely random, which we cannot control and we cannot model. So, white noise is a stationary model. Stationary model will have a constant statistical properties of zero mean, and it will have variance of the same. At the end of the day, if you make any test like ADF, the statistical properties need to be preserved. Uh, Now we have ACF plot and PACF plot. ACF is autocorrelative function and PACF is partial autocorrelative function. So we need to check these as well and to see what is the influence of, for example, nth timestamp. What is the influence of nth timestamp on n plus tth timestamp? That is what ACF will give. Partial ACF is what is the individual impact of the overall n plus tth timestamp. So these both needs to be considered, and always these things should be less than 95%, which is the blue lines that we get it, just to ensure you the proper PDQ, which is autoregressive difference and mm, uh, mean moving average part of for the time series to be considered. So end of the day, once you build the model and once it is finalized, if you want to find out MAPE, you just differentiate between the take the percentage difference between the difference between the forecasted value minus the actual value should give you the MAPE value. But MAP value is generally is not a right way of doing it, but this only it's not the only. There is a better way of doing it is using R squared, which will give you better insights into the accuracy of the model or the predictability of the model in this case. Thank you very much.